Okay, is Ben with us? I don't know if he's already in, but
Hi there.
to make a okay, Ben is, yeah. Good to see you, man. Just a brief
Thanks for having me.
introduction of you, and you can move on. So, guys, a session is called Jumpstarting Your Serverless Developer Workflow, and I've got few notes about Ben. He's a senior developer advocate for serverless applications at AWS in London, actually, and I found. Correct me if I'm wrong. I found um, how you express yourself. So you said I'm a data driven and love to see people use the technology I built to understand how it can be improved. Is it right, Ben?
Yeah, absolutely. So I'm a developer advocate working for AWS, but for 15, 16 years before that, I was a web developer. So I'm still very much focused on building stuff and trying out all the new features and all the new kind of services that we launch. And that's the most kind of interesting part of the job for me, to take that learning that I get and maybe those rough edges and give that information back to the product team, and then help other people to learn from that kind of head start that I get in getting to try some of the stuff out early on.
Okay, so I'm not stopping you from sharing the ideas you prepared for us. So the floor is yours.
Oh, thank you for having me. My name's Ben Smith, and I'm a senior developer advocate for AWS Serverless. And this is a talk all about jump-starting your serverless developer workflow. In this session, I'm going to talk about how the serverless developer workflow changes a little bit from a more traditional developer workflow. We'll talk about how to maintain a fast inner loop so you can iterate on your applications quickly while coding locally, and how to synchronize your application with an AWS developer environment. I've been at AWS for about 2 years now, and I'm currently doing some work on helping developers to get started with serverless technologies. So this is a content series for people who are already familiar with coding and building different types of applications, but are perhaps very new to serverless. I'm also a keen PHP developer, and I've done a lot of stuff around helping PHP developers migrate into using serverless technologies, and also on serverless orchestration using AWS step functions. And most recently, I'm focusing on the challenge of the serverless developer workflow, which of course is what's led me to this particular talk. So what's the main focus for today? Well, it's you really, the developer. And before I set about my kind of content plan for this particular talk and for my Getting Started series, I actually went out and asked the serverless community on Twitter what serverless means to them, and what the toughest thing was for them to get their head around when starting to learn serverless technologies. And I want to share some of the responses with you here, because I think it's actually really interesting what some people said. So the first response here is, just put my code to work. Don't care where the server is. Run it. And the difficulty they had is running serverless applications on their local machine. Another response says, code is a liability. How little code can I write by taking advantage of AWS managed services stitched together with direct integrations? Another one here says, focus mainly on the code, secure and easily scalable, combined with infrastructure as code makes it a joy to develop with. And the problems is I don't think there was anything tough, but yes, I learned to test as close to the real thing as possible. So integration tests and minimal mocking. And that's a really important thing that we're going to talk about quite a lot in this talk here. There's so many responses I got to this, and it's all really interesting stuff for anyone who is either new to serverless or looking at the different challenges with serverless technologies. It's a tweet worth looking at the responses to. It's from March 11th, 2020. I won't read them all out to you because they can broadly be summarized into three categories here. The first is that we see that developers want to focus on writing business logic, okay? And serverless is definitely a good enabler for this. They don't want to pay when their workload is idle, so only pay per use. And they want their application to scale on its own. They're the sort of three broad categories that we see the reason why developers are moving and migrating towards serverless technologies. So understanding the benefits of serverless is relatively easy. But if you start to move beyond the simple hello world implementations and beyond running one or two Lambda functions, then you very quickly need to start thinking about patterns and processes for serverless development, because you start to see how quickly the development workflow starts to change. So let's quickly have a look at the traditional developer workflow. And this is something that you often see from developers who are building more traditional applications before serverless, things like monoliths. And that's indeed the world that I come from. So I was a PHP developer for 15 years. And the most important thing, I think, when coding or building a new application is that you need to allow that application to run locally, so that you have confidence when you migrate that from your local machine to a development, staging, and production environment, that it's going to be as realistic and as high fidelity as possible to your local environment. And what you end up doing is trying to create that environment on your local machine so that you can test as you're building. And this is the kind of traditional developer workflow that we see people using. I'm focusing here on the inner loop, which allows you to write code, save your code, run your code, and then check the results and edit that code accordingly. And that's your inner loop, which you will run through before then committing to the main branch or to a feature branch, and then deploying and running various other types of tests. And that changes a little bit with the serverless developer workflow. So let's look at what's different. Now, the things that are different, there's more than three things, but they can fit into these categories, I think. The first is tooling. So most, if not all, of your tool chain is going to be in the cloud. I'm talking about things like Git repositories, code quality, linting, CI/CD engines, development and testing environment. And that's not to mention the different managed services that you're going to be using when building your serverless applications. The next thing that's different is mindset. So you might have heard before the idea of a serverless mindset. Really what it's about is constantly pursuing the most efficient route to providing business value by embracing managed services. And we'll talk a little bit about that in just a moment. The third thing that's quite different is monitoring. So if your tools are in the cloud, then your workflow also needs to make it easy for you to transition while you're developing from your local machine to remote and vice versa, so that you can check that the changes that you're building are working. So what's important? That's what changes with the serverless developer workflow, but what remains important? So the first thing is that you still need very fast fast code iteration cycles. So that will allow you to minimize context switching, and it will enable developers to quickly write and debug code as their application is built out. You need consistency. So that's consistency with the different environments: production, local, staging, development. And that's what helps you ensure that the functionality you're building will work when deployed to those different environments. And in order to have consistency, you need access to infrastructure. Iterating on the application's infrastructure and keeping these configurations consistent across the different environments is really important with any type of development, really. And in order to help you achieve these three things that are important, very quickly you will going to need to use an infrastructure as code framework, or an IAC framework. Now, there's a number of different serverless IAC frameworks. Some are listed here. You've got things like the AWS Serverless Application Model, sometimes called AWS SAM. You have the Cloud Development Kit, and both of these are open source. You've also got some great frameworks like Serverless and Architect and Chalice. And really, any one of these are really good choices to get you on the way to building serverless applications and improving your serverless development workflow. The other thing I mentioned is mindset. So you're going to have to think serverlessly as you build. And what do I mean by this? So the first thing is to think based on features. And what that really means is to try and avoid building a monolith wherever possible. Now, I don't really have anything against monolith. Like I said, I'm from the sort of PHP world where you have your entire code base or your entire application in a single code base. So you'll have all the different layers, things like your business logic, your data layer, your orchestration layer, notification, your authorization layer, all in most likely one GitHub repository. That's a monolith, and that can work great for a number of different applications, but it's not often the best way to build a serverless application. You want to focus on features that allow you to decouple all of those different layers from each other. And then you will use events to communicate between those different layers and those different components. Now, events are triggers that cause an action. So for example, an event could be a request to an API gateway URL, which then triggers a Lambda function to start running code. The third thing that will help you to think serverlessly as you're building is to think about statelessness. So this is the key to the sort of effective scaling of serverless technologies. And then finally, and I think this is the most important, is to use the services. So rely on using managed services wherever possible, and then add your business logic to fill in the gaps. Don't try and reinvent the wheel. So we're thinking serverlessly, but most of our coding is done in our local machine. Most developers are not yet using browser-based IDEs, such as Cloud9 and other IDEs that are out there. You're probably coding on your local machine for the time being. And in serverless applications, a lot of that code is actually configuration that help you tell the different managed services how to communicate with each other. And so if you're using managed services, but you're coding locally, then you're probably thinking that you need to emulate these services on your local machine or create mocks of these local services to test that your configurations are correct. So the question becomes, how do you mock these services to code and test locally? The best answer is that you shouldn't or don't, essentially. Don't mock services locally. And there's lots of good reasons not to do this, right? The main reason is that you don't have emulators for all the services that you're going to need to use. And those emulators that you do use, however good they might be, they're never going to support the latest and greatest features that are being launched from those cloud managed services. So don't mock services locally, but do mock event payloads. Remember, we said before that events is what allows your services to communicate with each other. And if you're mocking the event payload, essentially that's just a blob of JSON or a bit of data that's being provided from one service to the other. And that's fairly easy to mock. So for example, I might check out what my API gateway event payload is being provided to my Lambda function. I can take that payload as the raw JSON and save that as a variable or as a file on my local machine and provide that to my Lambda function as I'm testing locally. And I'll show you how I do that in just a moment. There's so many rules I wanted to put on this slide or tips that I wanted to put on this slide, but eventually it gets too messy. So we're going to have to break out into some more slides here. Really, when you're thinking serverlessly and coding serverlessly and coding locally, the main thing to take away is that you need to try to run your code in an actual cloud environment as early as possible in the development workflow. And that's really gonna fix most of the problems that you might run into later on. So let's take a look at the local serverless developer workflow. And all the same things are important here to the traditional developer workflow. You still need to run code, write code, check the results, check the logs. You need to iterate on your business logic as quickly as possible while building. So this is how some of our most successful customers do this. And this is, I think, a really good way to fix your inner loop when building serverless applications. So you have your business logic. So let's say for purposes of this demonstration that your business logic is a Lambda function. You create next to that Lambda function a test harness file. For example, you'd call that test harness.js if you were using the Node runtime. This is what that test harness file might look like. So you can see the first thing that it does is to require my Lambda function handler, something called API make order. Then it runs that function handler. and it outputs the results or any errors that it might receive, and it also outputs the amount of time that it took to run that bit of code. I also provide to that an environment variable, which, yes, it's in this example, it's hard coded in, but there's other ways you could make a single source of truth for that. But for the purposes of this demonstration, I'm hard coding in an environment variable which holds a reference to a table name. And then I'm also handing an event payload. So this is makeOrder.json is a test event payload from API Gateway. Then what I do is I use the CLI to run this test harness file, which in turn runs my Lambda function handler, and you can see the response there that I get from my function handler and the amount of time it took that code to run. Now, obviously, I would need the runtime installed on my local machine, which in this instance is Node, which allows me to run my test harness file. But running locally in this way actually gets you quite far along in your developer workflow before you then need to test your Lambda function and your application in an AWS account. But you will need to test your function in an AWS account before too long. And at that point, it's because you need to test how your function interacts with other resources, things like DynamoDB tables, API gateway URLs. You'll need to start testing your IAM resource policies, your security and authentication. Very quickly, you're going to have to upload your application resources to an AWS account. And we recommend to deploy that to an AWS developer account. So this is an account dedicated to each developer just for running their application. Now, as soon as you do this, you start to hit some of the big challenges with serverless, in my opinion, at least. The first is that every time you make even a small change to your Lambda function code, you now have to wait for your entire application stack to rebuild and redeploy. And this can take a few minutes sometimes. It can take 10 minutes if your application is very large. Also, now that you're testing against resources in the cloud, you have a lack of visibility into logs and traces unless you know exactly how to grab that information, which I'll show you in just a moment. And because of this wait time between redeployments, you're going to inject some context switching between the AWS management console and your local editor. And you're creating this idle wait time, which we know in serverless is not desirable, right? So AWS SAM Accelerate is a capability of the SAM CLI that was built very recently, and I think it was launched 4 weeks ago, with a goal to fix this specific problem. It increases infrastructure accuracy, it reduces deployment wait time significantly, and it aggregates console feedback. Essentially, what it allows you to do is to synchronize your local resources with a cloud developer account. Ideally, every developer on your team would have their own cloud developer account, so one account per developer. And this is how you can keep an application stack in sync with your local resources. So SAM Accelerate, this new component of the SAM CLI, has some new features, right? And I just want to quickly point out some of these new features before I show you how it works and show you it in action. The first thing is that it has a new way of implementing the SAM build command. It's able now to distinguish changes in code from changes in dependencies and infrastructure, and then it rebuilds only those artifacts that have changed. It also then allows you to synchronize code and infrastructure declared in your SAM template to an AWS environment using this new command called SAM sync. And if you add this watch command to it, it creates a background process which will then monitor all your project files for any changes, and it will automatically synchronize with the cloud as soon as it detects a change. So in effect, what this means is as you're coding locally in your Lambda function code and you hit Control Save, that automatically syncs your application directly to your AWS developer account. And it usually takes just a couple of seconds, depending on what you've saved. So how does it work? Why is it faster? The simplest way to explain why it's faster is because the SAM CLI is now using the AWS service APIs to push code changes to the developer account. Whereas before, every change you made would be uploaded with a cloud transformation routine that would then upload and update your entire infrastructure stack. Whereas now, the SAM CLI will distinguish between code dependencies or sort of code changes and infrastructure changes. So any change in code, and by code I mean a Lambda function code, an API gateway open API definition, or an AWS step functions ASL definition. If any of these changes are detected, it will use the relevant service API to upload that change directly to your AWS account. If you've changed an infrastructure configuration, then it will use the standard cloud formation transformation and upload that as before. The good thing is though, these architecture or infrastructure changes are far less frequent than changes in your code. So this helps you speed up your developer workflow significantly. There's also a feature called SAM logs. Now, SAM logs isn't new. It allows you to receive invocation logs from your Lambda functions directly to your console or your IDE, what you're working in. What you can do now, though, is you can include traces with those logs. So if you add this include traces flag, it sends both the CloudWatch logs and AWS X-Ray traces together directly to your console. And you can tail those logs as well. So that means essentially it's able to watch for any invocations within a second or so. It will send those logs directly to your console. So you're able to synchronize your stack with your cloud developer environment. Any changes you make are automatically uploaded. And then any invocations you make to any part of your stack, you can tail those logs directly back to your IDE. So this means for a large portion of your developer workflow, you don't ever have to leave your IDE. So it's much more efficient, much less context switching, much less deployment wait times. I'll show you just quickly a quick example of how this works, right? So here is my Lambda function handler. This is just written in Python. It's just a very simple hello world app. So the first thing I'm going to do is to run the SAM sync command, give it my stack a name, and I'm going to run the watch background process as well. So because I haven't run this before, it has to upload all of my application the first time I run it. So you can see now the infrastructure sync is now complete. In the next terminal here, I'm running SAM logs to tail the logs and the traces from that application stack. And here you can see previous log that's in my log group here. Now I'm going to send a curl request to that API gateway URL, which invokes my Lambda function. And you can see here's my response. Hello, how are you today? And here's the logs and the trace ID and the AWS X-Ray trace information in the terminal here. So that's showing how I can receive that log information directly in my console without having to jump into the AWS management console. Okay, so let's show you how the sync, automated sync and incremental build works. I'll change my Lambda function code just to change the message that's returned to hope you are well. And then I did Control Save, and that's automatically synced directly to my developer account in a couple of seconds using the incremental build process. I'd do another curl request to my API gateway URL, which invokes my Lambda function, and you can see the response is updated and my logs are coming through as well there. If I add a sort of console print, console output here, I'll say I have invoked, and I'll save that again by hitting Control S. And you can see once again, look, that's automatically synced using this incremental build process. And I'll invoke my Lambda function again via API gateway URL. There's my response. And in my terminal window here, I can see in just a moment, it will give me the logs and the X-ray trace output as well. Here we go. And if I scroll up here, I could find that print statement that I added to my Lambda function code. There we go, I have invoked. So that's just a very quick demonstration of how SAM sync works along with SAM logs to keep a synchronized version of my AWS a synchronized version of my application with an AWS development environment. What I would then do is once I've finished building out a feature and I've tested it to a certain point, I might use a CI/CD pipeline to then push that change out to my development account or my staging account or my production account, which might be shared with other developers at that point. And actually, there's a fairly new implementation of the SAM CLI called SAM Pipelines, which helps me create an entire CI/CD pipeline and all the AWS infrastructure that is required to run that pipeline as well. And this integrates directly with GitLab, with Jenkins, and with GitHub Actions, and with Code Commit too. So that's something certainly worth checking out, but I don't have time to demonstrate that in this particular talk. So here's my full serverless developer workflow. I have my inner loop where I'm still testing locally using my local CLI, and I provide my event payload and my local variables to my test harness. Then once I've finished the sort of quick local testing that I need to do, check that my syntax is correct and all that stuff, I'll use SAM Sync to synchronize my application with a cloud development environment. And then I can do so much more testing there, almost as if I'm working locally, because of the new incremental build and the background watch process is so quick. I'll use SAM logs to receive my log information along with my trace information from AWS X-Ray. And then when I'm happy with a certain feature, I can use SAM pipelines to make a Git commit and send that new change out to either production, staging, development, however you set up your pipeline file. So just to recap, serverless has lots of benefits for developers, which are pretty easy to understand and digest. And certainly everyone here today will know about these benefits. Certainly by the end of the last 2 days. It allows you to focus on business logic. You don't have to pay for idle, and your application will scale automatically. But building serverless applications does create new challenges. Things like, how do I test when I'm using managed cloud services? How do I get visibility when I'm building locally? How do I see what's happening with my application from within my local IDE? And how do I keep track of all this infrastructure that I'm creating? And one of the ways to help do that is to think serverlessly as you're building by using an infrastructure as code framework, focusing on events, and using the services, relying on managed services wherever possible. And serverless does change the developer workflow, but some ways around this is to not mock or emulate services, but do mock and emulate payloads. And I think the most important part of this is to run your application in the cloud as soon as possible, preferably in a developer account. And you can use tools like SAM Accelerate to help you do this. If you are interested in the roadmap of this open source tool of SAM CLI, then please go ahead and have a look at that and help contribute or put a pull request. Tell us what you would like SAM CLI to do next. It's always interesting for the product team. And that's really all. Thank you so much for your time. Thanks for listening to me. If there's any questions that I didn't manage to get to, or if you want to share how your serverless workflow is different, then I would love to hear about that. You can always reach out to me on Twitter. My name is Benjamin_L_S. And thanks very much. I'll hand back over now. Okay, bye-bye.
Thank you, Benjamin. Thank you for your session. I've already seen that we've got a few questions on the chat. So I know that you stick around the chat and you're actively asking Ben. So I'm leaving you with those threads from my side, Ben. If you don't mind answering on the chat, I would like to ask you what kind of problems or common mistakes you see that are being done by developers that enter the serverless world. What are the most common issues, and what would be your advice for them while they're entering the serverless approach and changing the mindset, which Alex mentioned yesterday about? So thank you once again. And right now we've got the last session for today from Wojciech Dąbrowski, so please stay with us. Bye.